Imagine stepping into a spacecraft, pushing a few buttons, and arriving at a distant star system in the blink of an eye. It's the stuff of science fiction, Star Trek, Interstellar, you name it. But today, we're diving deep into the actual physics that scientists have proposed for faster-than-light travel, wormholes, and the Alcubierre warp drive. The universe is big. Even traveling at the speed of light, about 300,000 kilometers per second. It would take over 4 years to reach our nearest star, Proxima Centauri. That's a long commute. So if humanity dreams about truly exploring the galaxy, we need ideas that go beyond conventional rocket science. A wormhole, also known as an Einstein-Rosen bridge, is a theoretical tunnel in spacetime connecting two separate points. Think of spacetime as a sheet of paper. You could travel across the sheet the long way, or fold the paper so the 2 points touch. That fold? That's the wormhole. In theory, a wormhole could let you travel from Earth to a star thousands of light years away in seconds. But here's the catch. According to general relativity, wormholes are unstable. They collapse faster than light can pass through them. To keep them open, you'd need something called exotic matter, a material with negative energy density. Ordinary matter, like the stuff making up planets and people, won't do it. Exotic matter is theorized to repel gravitational collapse, holding the throat of the wormhole open long enough for travel. There are big challenges here. We have no experimental evidence for exotic matter in the quantities needed, and maintaining stability might require enormous amounts of it. In 1994, Mexican physicist Miguel Alcubierre proposed a mind-bending idea. Instead of moving the ship faster than light through space, move space itself. Imagine sitting still inside a bubble of space-time while the space ahead of you contracts and the space behind you expands. Your ship is stationary relative to the bubble, but that bubble rides a wave in space-time at superluminal speeds. This warp bubble wouldn't violate Einstein's laws because locally, nothing inside the bubble would exceed the speed of light. The drive works by manipulating space-time itself. The problem? Just like with wormholes, the Alcubierre drive requires exotic matter with negative energy to make the warp bubble. And the energy requirements, according to early calculations, were absurdly high, more than the mass energy of the entire observable universe. Later refinements suggested the needed energy could be drastically reduced, but we're still talking about quantities far beyond our current capabilities. Exotic matter is central to both ideas because it allows space-time to behave in ways normal matter can't achieve. It's linked to the concept of negative pressure, which can counteract gravitational collapse in wormholes and shape space-time in a warp drive. One faint glimmer of hope comes from something we've actually observed, the Casimir effect. When two plates are placed very close together in a vacuum, quantum fluctuations create a measurable force that can be interpreted as negative energy density. But this effect is tiny, nowhere near enough for starship engines. Right now, wormholes and warp drives are mathematical possibilities, not engineering projects. They're fascinating playgrounds for physicists because they push the boundaries of relativity and quantum theory. We might learn that exotic matter can be created from quantum fields, or we might discover an entirely new physics that makes interstellar travel possible. In the meantime, these concepts inspire both scientists and storytellers. They remind us that the laws we know aren't necessarily the final word. They're the best versions we have so far. So maybe in a century or 10, we'll talk about trips to Andromeda as weekend getaways. Until then, wormholes and warp drives remain tantalizing possibilities, waiting for the day when human ingenuity meets the weirdest quirks of physics. And who knows? The journey to understanding them might be just as exciting as the journeys they could take us on.